When a block is proposed by a leader on the blockchain, the idea is that all of the other validators need to vote as to whether or not this block is going to be the new tip of the chain, the block that we're going to continue to build future blocks on. And so each individual validator must decide on its own whether or not to vote for that block. But once it is, or it has decided to vote for that block, it is committing to that block. In fact, it is declaring that it is going to fork off of the existing blockchain, and we are going to ride on this fork. And the hope is that everyone else in the Solana network agrees. We're trying to build a 2/3 supermajority by stake. And so if all of the other validators, or at least 2/3 of them by stake, decide that this is the correct block to continue building on, then the next block can be voted on. And in an ideal world, everybody agrees and we continue to move forward one block at a time. But what happens if this block is actually rejected by the rest of the Solana network? Meaning that this one validator decided to fork off on the wrong block, and meanwhile the rest of the network chose a different block and they're going to move forward using that one. Well, at this point, this validator is on a completely different fork. It's not able to vote on the next block in the correct chain because it has decided to build on this incorrect block. If the validator for any reason continues to vote on the incorrect fork, at that point, we're going to see all kinds of issues. This validator is going to be delinquent on the network because it's not voting on the correct blockchain up here. We need to get this validator to move from one fork to the other. And so it's going to recognize that, and it's going to want to switch over to the correct blockchain, the correct fork, and continue to vote along with the rest of the network. But there's a little bit of a problem with this scenario. The Solana network doesn't allow a validator to just switch forks anytime they want. And so this is going to trigger a lockout mechanism because the validator is going to have to wait in order to switch over to a new fork. In other words, this decision point here, this was a big commitment for the validator to decide to vote on this block. And now, because we voted on the wrong block, we're going to have to wait the lockout period before we can switch back over. So what exactly is this lockout period? Well, the lockout is meant to protect attackers from coming at the network and trying to switch back and forth between blocks in quick succession. This is an attack that could attempt to spend money twice, for example, and all kinds of other attacks could be based on voting on different forks, again, in quick succession. But it also serves as a punishment in this situation for voting on the wrong fork. We want the validators to make good decisions and not just vote as soon as a block is produced. We want the validators to make a good judgment call as to whether or not that block should be voted on. So how long is the lockout period? Well, it depends on how far back the validator needs to go. If we're just going back by a single block to rebuild off of that, well, the lockout period will be short. If we're going to have to go way further back into the blockchain because we continued to vote on the wrong fork, well, this is where the lockout period might take much longer. The formula for the lockout period is 2 to the x, where x is equal to the number of blocks that we have to go back during what we call a rollback. The rollback is going back in further into the blockchain and saying, this is the point where I split off and I'm going to now vote on the correct chain. So the number of blocks involved in the rollback is going to determine how long our lockout period is. And as for what we're measuring this in, this is a number of slots that we must wait. So we're measuring this in slots, not seconds or milliseconds or anything like that. So let's look at a few quick examples. Let's say that we realize that we voted on the wrong block here, and we need to go back just one slot. Well, if I have to go back one slot, then my lockout timer is going to be based on 2 to the 1, which is equal to 2 slots. So just by mistakenly voting on the wrong block, I'm going to have to lock myself out for 2 slots before I can start voting again. And so I'm not going to get any rewards for the 2 slots that I'm locked out. Okay, that doesn't sound all that bad up front. But again, this gets worse depending on how far back I have to go. So what if I realize that I voted on the wrong block way back here, and I actually have to go back 10 slots? If I have to go back 10 slots, now I have to wait 2 to the 10 power, and this is 1,024 slots, which is roughly 7 minutes of not voting. That doesn't sound that bad, but 7 minutes of not voting and not collecting rewards is not ideal. But I will say that 7 minutes is something that most validators can absorb. The interesting thing is when we look at the max slots, we can actually track this up to 32 max slots from the lockout perspective. So if we're looking at a 2 to the 32, that is roughly the equivalent of 136 years. So hopefully nobody gets locked out for 136 years because they had to go back 32 slots. But again, for the most part, when we're talking about lockouts, at least from an honest perspective, not necessarily somebody attacking the network, but honest validators usually don't have to go back more than a handful of slots because they'll realize that they're on the wrong fork pretty quickly. So how does a validator know how to go back and calculate the lockout? Well, this is where the tower file comes in. Every validator is going to store this file, and the file is going to track votes. So the validator and the rest of the blockchain, by the way, is going to know how this validator has been voting. Now, the tower file is just for local tracking purposes and for the lockout calculation. And so this creates an interesting situation because now the validator is going to build this tower file. And the reason why it's called a tower file is because we kind of imagine building up a tower of our last 32 votes. And so it's the last 32, and once we've voted at least 33 times, which happens pretty quickly on the Solana network, then we start dropping the votes at the top of the tower. So a new vote comes in, it gets inserted at the bottom of the tower, it pushes the rest of the tower up, and again, we're tracking the last 32 votes. Now, if we need to roll back to this vote right here, we can pop the rest of the votes under it, and we can start to rebuild our voting tower from there. Just keeping in mind that this also triggers that lockout period. So now I must wait however many slots is required. In our case, if we popped 3, it would be 2 to the 3rd power, which is 8 slots. And so this is going to be something that, interestingly, is self-enforced. You say, well, what's the point of having a self-enforced lockout period? Well, it's an interesting conversation. Solana says, by the letter of the law, that if we violate the lockout period, because the validators are able to do that if they so desire, then that could result in being a slashable offense. The problem is that Solana has yet to implement slashing, and as a result, there is no real punishment for the violation of the lockout period. Meaning that if a validator does find itself needing to wait 136 years, then at that point they can wipe the tower file and reload. So that means that they will have violated the lockout period, but again, they would rather be voting than not voting, and in the end, the network doesn't inflict any kind of slashing or any other form of punishment. Now, lockout violations are detected and tracked by the community, and validators that violate the lockout period, especially regularly, are going to get publicly called out. But that said, there are legitimate situations where the tower file isn't accessible, and as a result, lockout periods might get violated, and that's actually a pretty common situation that happens during major failover events with validators. So until Solana decides that it's a slashable offense, we're going to continue to see these types of violations on the network, but the lockout period does still serve a purpose, especially within the normal operation of Solana. Like this video, subscribe to the channel, and always remember to stake at the lake.